Hello, welcome. In this short video, let us look at the Meeman-Pearson likelihood ratio test for change in variance between the hypotheses. So, let us look at change in variance. So, under the null hypothesis, the observation x of n follows a normal distribution with mean equal to 0 and variance equal to sigma square naught. Under the alternate hypothesis, the observation will have a different variance. That is, it is taken from a distribution with a different variance. So, the likelihood ratio test is the probability distribution of x under the alternate hypothesis over the probability distribution under the null hypothesis is greater than the threshold gamma. Clearly, the probability distribution of the observation vector x under the null hypothesis is equal to the product n equal to 0 to n minus 1 of the probability distribution of each observation, which is 1 by 2 pi sigma square naught power 1 by 2 exponential of minus x square of n over 2 times sigma square naught. Under the alternate hypothesis, the observation model is the product n equal to 0 to n minus 1, 1 by 2 pi sigma square 1 over 1 by 2, exponential of minus x square of n over 2 times sigma square 1 or sigma 1 square. So, basically the difference between these two hypotheses is the variance of the distribution. So, the likelihood ratio test, that is L of x, becomes the likelihood ratio, that is L of x, becomes the ratio of these two distributions. That is, in the numerator we have the distribution corresponding to h1, which is 1 by 2 pi sigma 1 square whole power n by 2 multiplied by exponential of minus summation n equal to 0 to n minus 1. That is, the product of exponential becomes exponential of the sum. So, we have x square of n over 2 times sigma 1 square, and the denominator is 1 by 2 pi sigma square naught, that is 1 by 2 pi sigma naught square whole power n by 2 multiplied by exponential of the summation n equal to 0 to n minus 1 x square of n over 2 times sigma naught square is greater than the threshold gamma. Upon simplification, we can clearly see that the ratio of the first normalizing constants becomes sigma square naught over sigma square 1 whole power n by 2, and the ratio of the exponentials becomes exponential of minus 1 by 2 times sigma 1 square minus 1 by 2 times sigma naught square multiplied by the sum n equal to 0 to n minus 1 x square of n is greater than. So, taking logarithm on both sides, we have n by 2 logarithm of sigma naught square over sigma 1 square minus 1 by 2 times sigma 1 square minus 1 by 2 times sigma naught square multiplied by the sum n equal to 0 to n minus 1 x square of n is greater than logarithm of the gamma. So, by rearranging the terms, that is basically grouping the observations on the left side and all the constants on the right side, we have summation n equal to 0 to n minus 1 x square of n is greater than logarithm of gamma minus n by 2 logarithm of sigma naught square over sigma 1 square divided by this difference, which is 1 by 2 times sigma naught square minus 1 by 2 times sigma 1 square. We basically flip the sign, and then dividing with n on both sides, we have n equal to 0, 1 by n multiplied by the summation n equal to 0 to n minus 1 of x square of n is greater than 1 by n logarithm of gamma minus 1 by 2 logarithm of, and by flipping the ratio, we can make it plus 1 by 2 logarithm of sigma 1 square over sigma naught square, and the denominator is 1 by sigma square naught or sigma naught square minus 1 by sigma 1 square into 1 by 2. Therefore, the likelihood ratio test basically becomes the statistic T of x is greater than gamma dash. The test statistic T of x is equal to estimate of the variance of x of n, that is 1 by n summation n equal to 0 to n minus 1 x square of n. Clearly, T of x is the sample variance since the mean is 0, and the threshold gamma dash is equal to 2 by n logarithm of gamma plus logarithm of sigma 1 square by sigma naught square divided by the difference between sigma naught square, 1 by sigma naught square and 1 by sigma 1 square. So this is the threshold gamma dash. So to maximize the probability of detection, we basically have to check whether the statistic T of x is greater than the threshold gamma dash for a given probability of false alarm. Thanks for watching.